a look at our very first question here. Like I said, these are all past paper questions. If you go and have a look at past papers, you'll find them. But it is important to actually know how they're going to be examined. So in this first question, we have the diagram below has a graph of f of x equals ax to the power 2 is drawn in the interval x is less than or equal to 0. All right, so actually we'll come and interpret in a second. The graph of f to the -1 is also drawn. Remember, that is the notation for inverse. P, -6, -12 rather, is a point on f and is a point on f to the -1. So it's a point on both, and R. Let's put that in. And R is a point on f to the -1. Don't know why I left off the R, but anyways, we move. Alrighty, guys, so let's just go and add about the few things that we have here. So firstly, we've been given f of x is equal to ax squared. So remember, that is a parabola, and obviously the graphs are labeled for you, so you don't need to stress about being able to identify them because it is labeled. So that purple graph is our parabolic graph. Now already we should be thinking, okay, the a value is negative because it's a sad parabola. We were also told the interval or the restriction on the domain was x less than or equal to 0. And we can see that because all of our x values are negative. And that's also going to be important when we start talking about the inverse, but we'll get there. And then obviously we were given the inverse function, f to the -1. We don't have an equation for that, but that's fine. We're probably going to be asked the equation later. And that would now be this orange peachy graph over here. And we can see, if you imagine your y equals x line, obviously drawn much better than that, you can see that that is the inverse. It is a reflection of your parabola, can't say parabola today. It is the inverse of your parabola over or reflected over that line. Okay, so now that we've sort of established what's going on, we just need to remember that P is a point on my graph F, so on the parabola, and R, which we don't have a coordinate for, is on the inverse function. So that's the information we have. We can now go and start to answer some questions here. So the first question that's been asked is f to the -1 a function? Motivate your answer. Now remember, the way we check whether or not something is a function is we use the vertical line test. Okay, now you're not going to say it fails the vertical line test. That won't be your reason, but it is one way to check. And so if you take your ruler, if you drew a pencil line or whatever, I think a ruler is a lot easier on a piece of paper. Obviously, technology, I could move my vertical line. But as we move this vertical line anywhere along this orange graph, it's only cutting once. And so that means that it is a function. So yes, it is a function. Now, like I said, we're not going to give our reason as it passes the vertical line test. You need to be specific and you need to show that you understand what a function is. And remember, a function is that for every input, there is only one output. Okay, two different inputs can have the same output, but one input cannot have two outputs. So yes, for every x value or input, it doesn't really matter, there is only one y value. Right, so that's just a nice 1-mark question, testing whether or not you know the definition or the properties of what a function is. That's it. Okay, so you can use the vertical line to determine whether or not it is a function, but in terms of your reasoning, you actually need to go and state that you know that it's 1x, 1y. All right, so 1.2 says, 1.2 asks, if R is the reflection of P in the line y equals x, write down the coordinates of R. Okay, now often the words overwhelm us, but we shouldn't let them. So firstly, if we are reflecting over this line y equals x, remember we're talking about an inverse But we're also talking about a rule that says you take the original coordinates and you swap them. Okay, that's the whole idea that we've been working with when it comes to inverses. If we have a coordinate, if we have a characteristic, if we then look at the inverse, we are just swapping. So remember, domain swaps with range, range swaps with domain, x-intercepts become y-intercepts, etc. So we know that point P is at -6, -12. And if it is a reflection in this line, quite literally, all we need to do is take those coordinates and swap them. So R is at -12, -6, because that is what my reflection rule tells me to do when it comes to this line, y equals x. And that is what the inverse essentially is. All right, so read your questions carefully. Don't get overwhelmed by the language that's being used. I know it can be overwhelming, especially because now we're putting maths and English all in one go, and sometimes that's really tricky. But just read it carefully and go back to the basics. The line y equals x, inverse, swap, sorted. All right, so question 1.3 is asking us to calculate the value of a. Now remember, a was from your original quadratic. It's the coefficient to your x squared. Now, because we started off by saying, all right, this is a sad problem, we know that we should get a negative value. So just bear it in mind as we start to work it out. Always good to remember these things. So can someone tell me, and you can do it in the chat or you can unmute yourself, I don't really mind. Can someone tell me how we will now go and find this value of a? So given all the information we have, how will we go and find the value of a? Nice. Okay, so we're going to substitute our P coordinate. P is on the graph. Remember, as long as the point is, or the coordinate is on your graph, you can substitute it into your equation. Excellent. So we are going to substitute P, which we know is at -6, -12. That's going to allow us to find A. So we're substituting into f of x. I haven't left myself a lot of space here, but anyways, which was f of x is equal to ax squared. Remember, -6 is your x, -12 is your y. And so we've got -12 is equal to a times -6 squared. I'm just going to carry on up here. -6 squared is 36, so -12 is equal to 36a. We're going to divide both sides by 36, so we end up with -12 over 36 is equal to a. And that a then simplifies to -1/3. Now, we will just ask for the value of a, so we can stop there. But like I said to you before, I always then like to just write my equation because I can guarantee you're going to use it at some point. So it's always good to just have it there. At least then you've got the information. And if you need it, it's there for you to use. All right, so we know that that a value is probably correct because it's negative. So my parabola is sad. No issues, we're sorted. Now, this is what I'm saying. 1.4 says, write down the equation of f to the -1 in the form y equals. So remember, we should put it in the format they want, the y equals. And this f to the -1 is your inverse. And because we've written down what f was, it's easy for us to go and find the inverse. So f of x was equal to, and I'm just going to write this as -x squared over 3. You can write it as -1/3 x squared if you want. I just find that in terms of now going to find the inverse, this is a little bit easier. Remember, inverse, we swap x and y. So we've got x is equal to -y squared over 3. That doesn't look like a squared. Let's try that again. And what we now do is we solve for y. Now, this is where the information around the restriction on my domain is going to be important, but we'll chat about this in a second. Let's first find the inverse function. Okay, so we're solving for y, times by 3 on both sides to get rid of the fraction. So 3x is equal to -y squared. I'm going to divide both sides by that -1 to make y positive. So I've got minus 3x is equal to y squared. And we know that to get rid of a squared, we square root. So we square root, remember your plus or minus, -3x to give us y. Right now, importantly, is this plus or minus in front of my square root. We now need to decide, is it the positive square root or is it the negative square root? Now think about this carefully, guys. Sorry. Think about this carefully. If you look at your graph, your inverse function, which is, whoopsie, this bad boy in orange. Okay, so this is our inverse function. Its y values are all negative. Okay, none of these y values exist above the x-axis, so none of them are positive, all of them are negative, which means that I have to go with the negative square root of minus 3x, because that negative in front of the square root means that the value of whatever the square root is will be times by -1, giving me a negative. We know that we can never find the square root of a negative, so the value of that square root will always be positive, and then we've got the -1 coefficient. Importantly as well, we still have that restriction, and we need to always remember to include our restriction of x must be less than equal to 0. Again, if you look at your graph, you are only considering the inverse graph where x is negative. All of those x values are negative. So it goes back to that original domain that we were given. And so our function, or the equation rather, for the function of the inverse is y is equal to minus square root -3x. So I think, and obviously shout at me if I'm wrong, I think we would all be perfectly capable of getting to the point of plus or minus square root. It's then just going that extra step and double checking, is it the positive root or the negative root? And then remembering to accommodate or include your restrictions. Because if you don't include your restriction, then obviously you're saying it can be for any x value, which isn't true. So we always need to be mindful of what restrictions we have in place, and we need to abide by those. Alrighty, so I don't want to make this too small. Right. Let's screenshot that, and then if anyone has any questions while you're screenshotting, you're obviously more than welcome to ask. And guys, I do have the chat open, so if you do have questions while I'm going through, feel free to pop them in there and I'll get to them. Otherwise, like I say, you are also welcome to unmute yourself now if you would like, if you have questions. Otherwise, you're screenshotting and we're going to have a look at the second one. Right now, just for interest's sake, I have not actually, in the more recent papers, so I think this question was from 2019. I could also be lying to you, but in the sort of last 3-4 years, I haven't actually seen quadratics asked. Oh, excuse me. I haven't actually seen quadratic functions and their inverses asked in the paper. Obviously, they will ask you parabola and straight lines because that's grade 11 functions. But this type of question I haven't actually seen often. That is not to say that they won't ask you, because guarantee this year will be the year. But looking at a question like this is obviously important because it gives you an idea of how to handle them. They do more often than not ask log and exponential questions, because that is the one we focus on more in our syllabus. But just be mindful that you do still need to remember about your root functions. All right, so let's have a look at question 2. So question 2, we now have exactly that. We have now been given an exponential function of g of x is equal to half to the power x. And we've got a whole bunch of questions that we need to answer. Now, guys, before you even start with the questions, I would always just envision for myself, what is this graph? What does it more or less look like? Because when you are then asked questions like the range, if you have an image of it, it does make it easier. Okay, now firstly, our base is a fraction. When our base is a fraction, remember it's a decreasing function. So if I drew a very, very rough sketch of what g of x would look like. It would be a decreasing function with an asymptote at the x-axis, so at y equals 0. That is what my function looks like. If I wanted the y-intercept, you could very easily go and work it out, and we can chat about that in a second if we need it. But that is what the function looks like. So when it now comes to a question like question 1 or 2.1, where it says write down the range of g, that's easy. I don't even have to think about it because I've got a picture there. Range, remember, refers to your y values. And so all the y values where this graph exists is everywhere above the x-axis. And so my range would be y greater than 0. We are not including 0 because remember, that's my asymptote. It can't be included, but y greater than 0. If you're an interval notation person, which is cool, y element of from 0 to positive infinity, both of them getting round brackets because the 0 is not included because of the asymptote. We don't know where infinity ends, so a round bracket. Okay, so like I say, once you've got an image or picture that you can be guided by, makes life so much easier. And your picture doesn't have to be perfect, right? Just a sketch, but you have a general idea of what you're working with. So 2.2 says determine the equation of g to the negative 1 in the form y equals. Now again, remember, this is now asking me for the inverse. And we know that the inverse of an exponential is a log graph. And this is now where we need to go back to our log rule for converting. Okay, so I want you guys to try and find for me the inverse of this function. Bear in mind, or remember, that g of x was equal to a half to the power x. So I want you guys to come up with the to determine the equation of the inverse for me. Let's see what we get. Yeah, see one answer so far. You guys are doing really, really nicely. Well done. I'm going to give you one more minute and then we'll check. All right, so if you can look at this and you immediately know what it is, that's absolutely fine. I've said before that I always used to really struggle converting between log and exponentials and vice versa. So just remember, if it is something you struggle with, the first thing that we always do is we swap our x and our y. So this would be x is equal to half to the power y, and then we apply our rule. So y is equal to log of the base, which is a half, and the answer of that exponential equation. So y is equal to log base a half x. That's it. Right, obviously, if you can write the answer immediately, that is absolutely fine as well. You'll get the 2 marks, no problem. But just remember, first swap your x and the y, and then apply your conversion rule that we've spoken about. Alrighty, so question 2.3 says, is g to the -1 a function? Justify your answer. So what do you guys think? Is it a function? Yes or no? Again, I'm sorry if you can hear the shouting in the back. What do we think, guys? Is this log graph a function? You just have to say yes or no. Or thumbs up, thumbs down. Come on, guys. I know you know this. Thank you. Give me a thumbs up. Penicillin, nice. Thank you. So I'm assuming you're saying it is a function. I refuse to believe one person is going to give me an answer. Think about the vertical line test. If you draw the inverse, will the vertical line test, or will it pass the vertical line test? Caitlin, thank you. If it helps, if you go back up to the sketch that I drew earlier, this is not going to be the most beautiful looking function, but that would be your inverse function there. So that purple graph that I've drawn would be the inverse. And so again, guys, like I say, use a sketch. Tell me whether or not you think that's a function. I'm going to put it down to the heat, right? I'm not going to sit here forever. So yes, it is a function. Again, if you do the vertical line test, no matter where you put that vertical line, no matter where you move it along the purple function, it's only cutting once. Obviously, the closer to the asymptote, it gets a bit dodgy. But if you were to actually graph it properly using like a software, sorry, I couldn't think of the word, you will see that it only ever cuts once. So it is a function, and it's the same reasoning as before. There is only one y value for every x value. Alrighty. Okay, question 2. Yes, sorry. Question 2.4 says the point MA lies on the graph of the inverse. Calculate the value of A. Now, bear in mind, we have just worked out the equation of our inverse function. So we already know that y is equal to log base a half x. We know that. We're also now being told that this endpoint is on that function. So if I were to draw it, I would plot the point M at some point. And so what we've been asked to do is calculate the value of A in the first question. And so it goes back to what we said earlier. I think it was Kanyasile who said to us, you sub in what you know, and then you can go and solve. So A is X, 2 is Y. So we have got 2 is equal to log base a half A, and we're solving for A. Now, unfortunately, we can't put this in our calculator, but we can convert it to an exponential form. So the exponential form would be base, which is a half, to the power of your answer equals A. And now we can just work out easily A is equal to a quarter. So our coordinate for M is a quarter to. Again, write it down if you think it's going to be helpful to you. It might be, it might not be, but it's always nice to then have the final simplified answer. 2.4.2 then says M dash or M prime. We should actually say prime. I don't know why I said dash. So this is M prime. So that little apostrophe there is prime. It means the image or some sort of transformation has been applied to the original coordinate to produce a new coordinate. The image of M lies on G. Write down the coordinates of M. Okay, so M, which was a quarter to, was on the inverse. M prime, which we are wanting to work out, lies on my original graph G. So if we go back to what the relationship is between the inverse and G, remember, because it is the inverse, it is the reflection over the line y equals x. And because it's a reflection about the line y equals x, it means we've got that swap. And so all we actually need to do here to find M prime is swap M's coordinates to give us 2 a quarter. And that will give us our image. So it might seem like a really tough question and might seem like a bit confusing, but always break down your question to what information have I given you? What information do you know? How do they relate with each other? And that's exactly what I did. I knew what M was, and I knew it was on the inverse. I knew I was looking for M prime, and it was on the original. The relationship between the two is that reflection over the line y equals x. So all you do is apply your rule. All right, I don't want it to get too small, so I'm just going to hang 10 there. Take a screenshot of those first 5 questions, and then I'll do the last one. I wonder if we can. It might be a bit small. So take a screenshot. Remember, guys, obviously, if you have questions as we go along, please ask. But then we'll have a look at the last one, 2.5. Alrighty, so 2.5 says, if h of x is equal to g of x plus 3 plus 2, write down the coordinates of the image M prime on h. Again, so much information that's happening. So before we start stressing about the information, let's start with what information have I been given. So the first bit of information that I've been given is this transformation. So this bracket, I don't know why I've done this, but anyways, we'll just remove or roll. And grade 12, break it down for yourself. You know what each of these parts represent. So for example, this whole g of x plus 3, that is affecting my x values. If your x values are being affected, you're shifting left or right. And we know, because we know that x minus p is a shift right and x plus p is a shift left, we know that this is a shift 3 units left. Right, so always remember, if it's x plus or minus, you're shifting left or right. When we now consider that plus 2 at the end, it's not attached to an x or anything, so this is now affecting my y coordinates, or my y values. Anytime your y values alone are being affected, it's a shift up or down. So this is telling me that I've shifted 2 units up. Okay, so all you've done is you've taken the first part of the question and you've broken it down. We can now move on to the second part of the question. The second part of my question said, write down the coordinates of the image of M prime. Okay, image of M prime just means where will M prime move to once we perform this transformation. So M prime was at 2/4. What we now want to do is we now want to take this transformation that we've identified and we now want to apply it to M prime. If we can apply it to M prime, we can get the image. Technology is just having a bit of a moment with me. We'll get there. Right. So if we think about taking the x coordinate and shifting it 3 units left, you're currently sitting at +2. 3 units left will now take you to -1. Now, guys, we've already got M prime. I don't know how many of you remember this from grade 8 and grade 9 transformation geometry. You're now creating a new image. So now we use M prime prime or double prime. Again, you're sitting at, if you consider your x-axis, you're sitting currently at 2. You now need to go 3 units left, 1, 2, 3, taking you to -1. You were sitting at 1/4 on your y-axis, and now you want to go 2 units up. So now you're at 2 1/4. Sorry, I'm going to sneeze. Bless me. Excuse me. I do apologize. So you were sitting at 1/4. You now want to go another 2 units up. So now you're at 2 1/4. Now you can leave it like that if you want to. Personally, I don't like mixed fractions, so I would convert this to 9/4. But we're not going to mark you down if you leave it as a mixed number. So guys, questions like this are not tricky. The issue comes in reading with understanding, essentially. Looking your question, breaking it down, understanding what information you've been given and how you can now use it to find what you want. For this one, again, I would really recommend, as I say every lesson, going over your grade 11 functions and having a look at the types of questions whereby transformations are asked. Whether it's a shift up or down, a reflection, whatever the case is, there's 2 or 3 marks, but there are 2 or 3 marks that you can guarantee if you can get them right. And this question, like I say, not a hard question. It was just reading with understanding the information that had been given to us. Right, so I'm going to stop, take a screenshot, and then we'll have a look at question 3. Okay, so if we have a look at question 3, we have been given the graph of f of x equals log base 4x is drawn below. So only graph we have, so we're not stressing about multiple graphs, one graph, and it's a log graph. We can also see that there's a coordinate on this graph at B. We don't know the full coordinates of B, but we do know it's at K2. So we don't know what the X value is, but we do know what the Y value is. And unsurprisingly, the first question says, calculate the value of K. Now, again, because it's a coordinate, similarly to what we did earlier, all you do is substitute in. So y is equal to log base 4x. Y is 2 once we substitute in. X is k. And so now we can convert to an exponential form in order to figure out what k is. So I'm going to give you like a minute. Determine for me the value of k. Very so nice. Okay, guys, so it's base, so 4 to the power 2 equals k, and so therefore exactly k is equal to 16, and you do now know that the coordinate of b is 16, 2. Might be helpful, might not be, but at least now we have that information. So 3.2 now says determine the values of x for which f of x is greater than or equal to -1, but less than or equal to 2. Again, it looks overwhelming and it looks scary, but it isn't. We break down the information that we have. So firstly, we're referring to our graph f of x, which is the log graph that we were given. So we're happy that is the only graph that we're working with. It can't be anything else. Now, guys, remember f of x is a fancy way of saying y. So it's asking me, or it's telling me to look at the x coordinates where y is only between -1 and 2. So let's, for argument's sake, just draw an imaginary line at y equals -1. And we can see that y equals 2 is at that point B. So what I want to know is what is this x value over here? And what is this x value over here? Now we already know the x value at B because those two x values are the portion of my graph where it's from -1 to 2. That's all I need to find. We already know the x value at 2. We've just worked it out at 16. We need the x value at -1. Now that's fine. In order for us to find that, we just go and substitute in. Oops. So y is equal to log base 4x. We're going to substitute in the y equals -1. So -1 is equal to log base 4x. We can now convert to exponential. So 4 to the power -1 is equal to x. And so x is equal to a quarter. Remember, that's what 4 to the power -1 means. And so what that means is here, my x value is a quarter and my y value -1. And b, obviously, we already know. So my x values are from a quarter all the way up to 16. All right, so again, not a tricky question, but it's reading your question with understanding and then breaking down what information you have, how are you going to use it. Again, it's a 2-marker, so you spend 2 minutes on it. If you get it, great. If you don't, you move on. But the really important thing, guys, is reading with understanding. If you can do that and if you can practice that, it will be so much easier for you. And the only way you do that is to go through past papers to see how the questions are asked. Once you see how questions are asked, it's much easier to understand the questions moving forward. Right, 3.3 is asking for the equation of the inverse in the form y equals. Now remember, we were given the log graph, which means the inverse is an exponential graph. So 60 seconds, give me the equation of your inverse. And remember, if you're feeling a bit confused about your rule, start by swapping x and y, and then you can apply the rule. I will rewrite the rule for you as well. Okay, so what is the equation of the inverse? Like I say, you know the original is a log, so the inverse must be an exponential. No answers, grade 12. So we're just having a bit of a slow Monday. Right. Using your rule, y is equal to 4 to the power x. Okay, so let's just double check to make sure that we're all on the same page. So remember that your log function was y equals log base 4 to x. So when we swap the x and the y, we now get base to the power of your answer, x, is equal to y. So that's how I knew it was 4 to the power x. The quarter came from my substitution in 1. So a quarter was just a random x value. Our base in this case is 4. Right, so let's take a screenshot of this so long, and then we'll have a look at the next question, which is, again, one that I think sometimes freaks us out, but doesn't have to. Alrighty, so I'm just going to make that a touch bigger because I'm going to want to use the graph in a second. We have been asked in 3.4, for which values of x will x times the inverse be less than 0? Now again, let's break it down. This is saying to me that I'm taking x values, whoops, I'm timesing it by the y values of the inverse, and the product must give me a negative answer, because if it's less than 0, it must give me a negative. Okay. Now, my inverse function is an exponential. It is, just take all the scribbles off. It is an exponential that has the equation y equals 4 to the power x. Now, my inverse is not going to be perfect, but we're just going to roll with it. It would look something like that. Okay, that is my inverse function. Again, not perfect, but that is what it is. Now, if we go back here, the only way for me to get a negative product is to say a positive times a negative or a negative times a positive. So either my x value should be negative and my y value positive, or my x value negative and my y value positive. So let's go back up to my beautiful sketch. As you can see for my inverse, my y values are all positive, all of them. There's not a single negative y value. So we are now working with a situation where those have to be positive, which means my x values have to be negative. Excuse me. Now my x values are only negative for this portion of my graph, this end section here. This is where x is negative because it's on the negative x axis. And so this is again what I'm saying to you guys. Break down what you have, what information you're working with, and then refer back to the graph if necessary, refer back to the information you have, and you can work it out. We therefore know, sorry guys, that here we've got positive y times all of these negative x's giving me a negative product. On the other side, my y is positive, but my x is also all positive. A positive times a positive is a positive. It's not giving me the negative. So it has to be all of the x values below or less than the origin. And so here, the answer we're looking for is x less than 0. Not equal to 0, because I didn't care where it was equal to 0. I just care where it is less than 0. So x is less than 0 is your x values that we're looking for. Again, it's a 2-mark question. You spend 2 minutes on it. If you get it, great. If you don't, you move on. But once you break down what it is you're actually working with and you understand what the inequality is saying and what values you're working with, again, it becomes a lot easier. But these things only come with practice. So you have to go practice past papers, grade 11 papers, all of that. Right, I can't actually remember where I said screenshot. So I'm just going to put it back up like that. Take a screenshot. And then hope, I don't think we'll have time for all of question 4, but we'll see how far we get. Right, guys, while you're taking screenshots, please do remember to do your quizzes. I know we've been having many issues. And like I said, I'm trying to sort it out. I think we figured it out. But again, if you've got problems, you just request access within 24 hours, it'll be sorted. But please do remember to do your quizzes, and obviously remember to tell your friends about MathsLive, get your friends to join us. You can just give them the website or whatever, but yeah, it would be awesome if we had more of you joining us and your friends joining us. Alrighty, let's have a look at question 4. Like I said, we probably won't get through all of it, but it's fine. We can carry on Wednesday if need be. So question 4, this was from last year's November paper, last year's final paper 1. So this is what the matrics of last year wrote, and this was their inverse functions question. So sketch below is the graph of f of x is equal 2 to the power x minus 4 for the interval of x element negative 2 to 4. A and B respectively are the y and x intercepts of f. Okay, so a couple of things we want to break down, a couple of things we want to make sure we understand. We've only got one graph, we're happy with that. Remember, this is our asymptote because we can clearly see that the graph has been moved down. So this is at y is equal to negative 4. The next thing that we were told is the interval. So the next thing we were told that we're only considering the x values between negative 2 and positive 4. Now you can see this. The graph stops at negative 2. The graph stops at positive 4. Really importantly, negative 2 is included because it's a colored in dot and it is square bracket, whereas 4 is excluded because it's a round bracket and an open dot. A and B are the y and x intercepts respectively. We can see that on the graph that's been labeled for us. So the first question is asking us, write down the equation of the asymptote of f. We've already done that. Just by taking 10 seconds and understanding all the information we were given, we automatically have that answer. 1 mark done, no problems there. Question 4.2 is asking you to calculate the coordinates of B. Now remember, B, you can look at your graph or go back to the information, is your x-intercept. Your x-intercept is where you now make y equals 0. And so we would have 0 is equal to 2 to the power x minus 4. Now that's an exponential equation. So this is 4 is equal to 2 to the power x. You make your bases the same. Once your bases are the same, you can equate your exponents. So x is equal to 2, which means that, whoopsie, don't know why that happened, which means that B's coordinates are at 2, 0. And we can see that on the graph, it definitely is a positive x-intercept. We're happy with that. So x-intercept make y equals 0, y-intercept make x equals 0. Question 4.3 says, determine the equation of k, a straight line passing through A and B in the form of k of x. Right, I think this is going to have to be our last one, so that's fine. So if we imagine what's happening, this straight line has to pass through A and it has to pass through B. I don't know how wonderful my straight line is going to be, but I'm going to try. It wasn't the worst thing I've ever drawn. So that's a graph of k. I want the equation of it. Now, really importantly, we need to notice that it has the same y-intercept. So if we can figure out what the y-intercept of my exponential is, it's going to be exactly the same as my straight line, and that's half the information I need. So for us to find the y-intercept, as I've already said, we're going to make x equals 0. And so now we've got y is equal to 2 to the power 0 minus 4. And so the y-intercept is at negative 3. So that means A has a coordinate 0, negative 3. But it also means in terms of k of x, I've got k of x is equal to mx minus 3. I know what that c value is. Now I just need to go and find m. To find m, you can either use your coordinate for A and your coordinate for B and use your gradient formula, or you just sub in your coordinate of B. So 0 is equal to m times 2 minus 3, which means that 3 is equal to 2m, which means that m is equal to 3 over 2. So k of x is equal to 3 over 2x minus 3. Right, so again, not a tricky question at all. It's about reading with understanding. what I said earlier as well in terms of draw on your graphs, sketch your graphs, do what you need to do. Because I drew the line going through A and B, I can clearly see that the y-intercept for both the exponential and for the straight line is the same. And so if you then need to use your exponential graph to find your y-intercept, fine, it's the same point, it doesn't matter. We were able to get that coordinate and we were able to then go and solve for our straight line equation. All right, there are a few more questions for 4, but what we'll do is we'll finish that off on Wednesday because I don't think I'll get through all of them. Okay, so what I'll do is I will put this question up again on Wednesday, and we'll finish it off, and then we'll have a look at some exam type questions. Most of them are grade 11 functions, as I've already said to you, but we'll finish this off on Wednesday and then carry on. Again, guys, please do the quizzes. They all should be accessible. And obviously pass on to your friends about MathsLive, your family, whoever, especially as your first set of exams is coming up in June. It is really important that we are helping as many people as we can and working with as many as we can. So please do. Otherwise, you guys are more than welcome to leave once you've taken your screenshots. I hope you all have a lovely Monday evening, and you said Wednesday evening. And I will see you guys on Wednesday.